Today we're going to cover the Pythagorean theorem, okay? What is a theorem? A theorem is a truth in mathematics. What kind of truth are we talking about here? We're talking about right triangles and the truth that your two shorter sides, when you square them and you add them together, it'll equal your longer side squared. We're going to have to memorize a squared plus b squared equals c squared. That is the Pythagorean theorem, okay? The c value will always be your longest side. So here's a picture straight from the text. It says a Pythagorean theorem. What is it? What's a Pythagorean theorem? In a right triangle, what does a right triangle mean? It means a triangle that has a 90-degree angle, a perfect corner, 90 degrees, right? In a right triangle, the side opposite of the right angle is called the hypotenuse. So if here's our right angle, which one's a hypotenuse? It's the c value, okay? So you might want to jot down a triangle like this and put a little square right there. That means that that's a 90-degree angle. And if you know that this is the 90-degree angle, let me highlight it. If you know that that's the 90-degree angle, then this guy over here, opposite of it, is the c value, which we know is the hypotenuse. Hypotenuse. Okay? And that hypotenuse in the Pythagorean theorem is the c value always. Now, the book writes it c squared equals a squared plus b squared. For some reason, when I was in high school, we would always write it a squared plus b squared equals c squared, okay? And what are a and b? What are the values of a and b? They're simply the shorter sides. Here's one shorter side, here's the other shorter side, and the hypotenuse is the longest side. How do you know which one's the longest side? Well, right here you could see that it's longer, but even if you had a triangle that kind of looked like let's say it looked like all the angles were exactly, or all the sides were exactly the same, but if they put like a little box right here saying that this right here is a 90-degree angle, I know that's horrible, then that means that this would be the c value, the side opposite of it. Okay, so let's first practice identifying that. So on this triangle right here, which one would be the c value? Would it be this one? Yes or no? No? How about this one? Yes or no? Yes. Why? Because it's opposite of the 90-degree angle. Here's your 90-degree angle. Opposite of it would be the hypotenuse. So this would be the c value right here, okay? Because it's opposite of the 90-degree angle, okay? How about this guy right here? Is this the hypotenuse? No. Is this a hypotenuse? No. Is this a hypotenuse? Yes. Why? Because opposite of the 90-degree angle. C value's right there, okay? How about this guy up here? Here's a 90-degree angle. Opposite would be this side right here. So this side right here would be the c value, okay? The hypotenuse, the longest side. Anyway, we need to remember this truth that a squared plus b squared equals c squared, and we're going to be able to solve problems where we have triangles, right triangles, that have missing sides. Very important that we understand that the hypotenuse, or the Pythagorean theorem, better said, only works with right triangles. You have to have a 90-degree angle. So like if I had something like this, like, oh, I got that side, I got that side, then I got this side. This is not, you can't use the Pythagorean theorem here because this is not a perfect corner. This is a obtuse angle. It's bigger than 90 degrees, okay? Anyway, let's use this truth, use this theorem, a squared plus b squared equals c squared, to solve our first problem. Okay, so you're gonna have this type of question on quizzes. You're going to see this picture. It says a right triangle has the sides 3, 4, and you don't know the hypotenuse. You don't know the longest side. So we need to figure it out, okay? Just got to move this to the side for a bit to have more space. And again, let's write down the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared, where your c is your longest side, which is a hypotenuse, which is opposite the 90-degree angle. So once you identify C, which is opposite of the 90-degree angle, the other two sides are simply your A and B, and it doesn't matter which one you call A, which one you call B. They're the two shorter sides. So what do we have here? We have, let's call this guy A. Let's call this guy B. So we have 3 squared plus 4 squared equals C squared. So everybody write that down. Now, once you have this set up as an equation, now you could solve it using algebra. You could use your calculator if you want, or you could think about it. 3 squared is 9, and 4 squared is 16. And of course, you are adding them together, and you still have the equal c squared over here. Again, you want to find this missing value c. You want to know what that distance is. So let's do the math. 9 plus 16 is 25. And you have equal c squared. So c squared equals 25. I like having the c on the left side and the number on the right side. And you don't want the square. So to get rid of something, you do the opposite. The opposite of a square is what? Square root. So we do a square root here. And what you do to one side, do to the other side, square root there. So our answer is c equals plus or minus, because whenever you do a square root in an equation, you have to put a plus or minus in front of your answer. C equals plus or minus 5. Now, we are talking about the actual measurements of a triangle. This is probably 3 inches or 3 feet, whatever the unit of measurement is. This is 4 inches, 4 feet, who knows? But there's no such thing as a negative distance. So because there's no such thing as a negative distance, you don't have to put the plus or minus. You're just going to put C is 5, right? But if it were a regular equation, you would put plus or minus 5. You have 2 answers. But because we're talking about actual measurements of a triangle, you can't have, how much does it measure from here to here? It's not negative 5 inches. It has to be a positive number. So you don't have to put a plus or minus. It's just C equals 5. Okay. Now, if you look at the instructions, it says state the missing side. We already know the missing side is 5. That's our answer. That's what you type in. You just type in 5 and you're done. You got full credit. But notice the rest of the instructions. It says, please type it in simplified radical form. Sometimes you're not going to get nice answers like 5. Sometimes you get crazy, irrational decimals. And you want to leave it as a simplified square root, a simplified radical. And we'll get to those in a bit. Let's try another. Okay, so right here we have another triangle. Everybody jot it down. It says state the missing side. If you have an irrational answer, a crazy decimal, please type it in simplified radical form. So let's begin with the Pythagorean theorem, writing it down. A squared plus b squared equals c squared. So what do I put in place of a? What squared? Anybody? 4 squared. Okay, so let's put 4 squared plus b squared. Do I know what b is? No, we're trying to find what b is. Okay, so b squared equals c squared. What is c squared? Yeah, 21, the side opposite the 90-degree angle. So we're going to put 21 squared. Okay, so you're definitely going to use a calculator on a lot of these questions. I mean, 4 squared is easy. 4 times 4 is 16. 16 plus b squared equals now 21 squared. I don't know. I want to go to a calculator and just type in 21, and here's the square button. 21 squared, hit equal, it'll give you 441. All right, so we have 441. Okay, so what next? Well, we need to get b by itself. They want us to find what b is. B is clearly on the left side of the equal sign. It has a square and it has a plus 16. I don't want this addition of 16, so I want to get rid of it by doing the opposite, minus 16, minus 16. And on a calculator, 441 minus 16, just to be safe, is 425. Let me get this calculator out of the way. I just did it on the calculator. So we have b squared equals 425. And for my final step, to get rid of a square, what do? Square root. And what I do to one side, I must do to the other. Now, normally, we'd end up with a plus or minus, like a plus or minus in front of our answer. And of course, the square root of 425, you're going to do it on a calculator. That'll give you 5 squared to 17. 5 squared to 17. Okay. So yes, all I did was type in this square root button and then typed in 425, hit equal, and it gave me the simplified radical form. Now, this calculator is nice. Other calculators, when you do a square to 425, it may give you the crazy decimal, which would be 20.61552813. This is what I'm talking about, simplified radical form. So you don't want a decimal. You want it simplified as a square root. So 5 squared to 17 is your answer there. And once again, if it were just algebra, if you're just solving the equation, you would say b equals both positive 5 squared to 17 and negative 5 squared to 17. But because we're talking about an actual shape and we're talking about the actual measurement of a side, there's no such thing as negative distance. So we don't have to put a plus or minus. You only want the positive of it. So b equals positive 5 squared to 17. And that's what you would type in to get full credit on this answer. Let's try another. And on this one, for sure, let's use calculators, right? Again, you're going to begin with the Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. Which one's a c value? Anybody? 39, opposite the 90-degree angle, 39. So we're going to put a 39 squared right here. Let's do that. 39 to the second power. Then we have a squared, which obviously we don't know a, so that's what I'm going to write. A squared plus b squared, which means that b has to be 15. So we have 15 squared. And we need to solve this thing. So with the calculator, go ahead and do 15 squared, which is 225. And we'll have a squared plus 225. Again, I just did that on a calculator and I got 225. Equals 39 squared. 39 to the second power on a calculator is 1521, 1,521. Okay. And of course, you need to get a by itself. So let's get rid of the 225 by subtracting 225 on both sides. And again, with the calculator, I just go 1521, take away 225, and it will give me 1,296. So 1,296. And we have the a squared on this side. Now, at this point, let me show you what I have on my calculator so far. So I ended up with this answer the last time I did 1521 take away 225, and I got this. So there's my answer, 1,296. Now, if I want to apply a square root, right? Because to get rid of the square on the a squared, you got to do a square root and you got to do a square root. So if I want to apply a square root to this answer, since it's already on the screen, all you have to do is hit the square root button and then hit this ANS. That means the previous answer. So if you hit square root answer, it's really going to do the square root of 1,296. So I did hit the square root and then the answer button, and that's a lot faster than typing in the square root of 1,296. But square root answer, hit equal, and it gives you 36. So our a value, a equals 36. It should be plus or minus, but we know there's no such thing as negative distance, so we just say a is 36. Let's do another. How am I going to set this up? Again, same deal. A squared plus b squared equals c squared. A is a. B is what? 6 squared plus c, which is 19 squared. Okay? And let's do the math. We could do this in our heads. That's 36. So you have a squared plus 36 equals 19 squared. That's the one you have to use a calculator on. That's 361. And then if we take away 36 from 361, we get 325. So we end up with a squared equals 325. To get rid of that square, you apply a square root. What you do to one side, you do to the other side. A equals, you don't need the plus or minus because this distance is always positive. But with the calculator, do the square root of 325. And that will give you the simplified answer 5 square root of 13. 5 square root of 13. And it does say, type it in simplified radical form. It's important that you read the instructions. If for some reason you're taking a different test and it says round your decimal answer to the nearest tenths, then you would actually have to convert it to a decimal. You see a is on a calculator 18.027756638, and it keeps going forever and ever and ever. It's irrational. So if the instruction said round it to the nearest tenth or nearest hundredths, right? You would say, okay, hundredths would be this one right here. So you look at the 7 and it would change that 2 to a 3. So 18.03 would be the decimal approximation to the nearest hundredth. But on this section in our books, I do ask for it in simplified radical form, not as a rounded decimal, okay? Anyway, That's the first half of the lesson. The second half of the lesson is just as easy. The converse means that if something's true in a certain way, in an if-then statement, then backwards, it's also true, right? So if you exchange the phrases after if and if-then statements, then the result is the converse of the statement. The converse of a Pythagorean theorem can be used to determine whether the triangle is a right triangle, okay? So if I give you a triangle and I ask you, is it a right triangle? You could double check and see if it's an actual right triangle by checking a squared plus b squared and seeing if it does equal the hypotenuse squared. So if it's true, then it is a right triangle. As a matter of fact, I have an uncle that has a construction company, and he was working on my house once, and we needed to check. He was putting the form of the cement, so it was a corner, right? And there's a special tool that will help you make sure that this is a 90-degree angle. But he just said, use 345. And I'm like, what the heck? What do you mean use 345? And he says, if you measure from this corner out and you go 3 feet, and you measure from this corner out and you go 4 feet, and then if you measure from this ending point to this ending point, if that is a 5, then that guarantees that this is a perfect corner. I'm not making this up, right? This is what my uncle actually does in his construction company, right? And then I later realized, oh, he's talking about the Pythagorean theorem, right? If you actually do a squared plus b squared and it equals c squared, then it's a right angle. So 9 plus 16 equals 25, and that is true. 9 plus 16 is 25, and 25 equals 25, which guarantees it. You double checked it. Yes, it is a right triangle. It's 90 degrees. Okay. Not only that, this is what we call a Pythagorean triple. Okay. Nice numbers, 3, 4, 5. Nice numbers that come from a 90-degree angle that come from the Pythagorean theorem. So it says right here, a Pythagorean triple is a group of 3 counting numbers. Like counting, we're talking about non-square root numbers, right? Like actually like 3, 4, 5. Right, that's a Pythagorean triple. And you could use multiples of this Pythagorean triple. In other words, this could have easily been 6, 8, and 10. All I did was multiply the 3 times 2, the 4 times 2, and the 5 times 2. And that's a Pythagorean triple. If you double check that, like if you went 6 squared plus 8 squared, it will equal 10 squared, right? That's 36 plus 64. That really does equal 100. 100 does equal 100. So the Pythagorean triple, 3, 4, 5, you could multiply it by whatever you want, and it'll still give you a perfect 90-degree triangle, okay? So how are we going to use this on questions? Let's check it out. Here it is. If a triangle has the sides 9, 15, and 12, is it a right triangle? Let's start with that. Imagine a triangle that has 9, 15, and 12. Could somebody tell me how to set up the Pythagorean theorem here? What squared plus what squared equals what squared? Help me out. But with the actual numbers here, 9, 15, and 12, what do I write? 9 squared plus 12 squared equals 15 squared. Thank you so much. That's great. You realize that 15 is the longest side. That has to be your c squared, your c value, right? Okay, cool. So now you actually do the math here. 9 squared is 81. 12 squared is 144. 15 squared, I forgot. I'm just going to do it on the calculator. 15 to the second power is 225. So let me double check. 81 plus 144 on a calculator. 81 plus 144. It is 225. Okay, 225 equals 225. So what does that tell you? That it is a 90-degree triangle. Okay, it is a 90-degree triangle. Okay, so is it a right triangle? Yes, it is. Are these sides a Pythagorean triple? Yes, it is. Why? Because they're nice, right? You have the 9, 12, 15. Okay. As a matter of fact, if you divided 9, 12, and 15 by 3, you end up with that Pythagorean triple that my uncle uses, 3, 4, 5. 9 divided by 3 is 3. 12 divided by 3 is 4. 15 divided by 3 is 5. 3, 4, 5. Anyway, so we found out that it is a right triangle. So it says right here, yes, this is a right triangle. and these numbers are a Pythagorean triple. So this right here is your correct answer. Just to let you know, the other options, yes, it's a right triangle, but these numbers are not a Pythagorean triple. That might happen. No, this is not a right triangle, but the numbers are a Pythagorean triple. That doesn't even make sense, actually. And no, this is not a right triangle, and the numbers are not a Pythagorean triple. That could happen as well. Anyway, this is the correct answer. Let's try another. How about this? A triangle has 5, 7, and the square root of 74. Okay. Now, you might be thinking, well, which one's the longest side? You could check on a calculator what the square root of 74 is and change it to a decimal. That's 8.60232527.6, blah, 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 keeps going forever. So obviously, the square root of 74 is your what value? A, B, or C? The longest side, C, the hypotenuse, right? So how do we set this up? We're going to set it up 5 squared plus 7 squared equals the square root of 74 squared. You might want to put that in parentheses just so you could understand it better. Anyway, you might be freaking out right here when you have, oh, what, the square root of 74 squared? That's going to be crazy. As a matter of fact, you should love this. Why? Because the square root is the opposite of a square, which means that when you square a square root, it undoes itself. It's like saying, what's 5 plus 3 minus 3? It's just 5, right? What's 7 plus 1,000 minus 1,000? It's still 7. When you do the opposite operation, it eliminates. So the square root of 74, but when you square it, it just leaves you 74. The square root and the square eliminate themselves, and you just have the nice number 74. So that's even a better situation than before because you don't have to do any math. You just scratch it out. So what is 5 squared? That's 25. What is 7 squared? That's 49. So if you do 25 plus 49 on a calculator, it does give you 74. So 74 does equal 74, double checked it. So we know that this, yes, it's a right triangle. Yes, right triangle. It's 90 degrees, yeah? Now, are these numbers 5, 7, and negative 70, or square root of 74 a Pythagorean triple? Heck no. Why not? Because of the square root. It says counting numbers. This is not a counting number. This is an irrational number, right? So if this were like a 3, 4, 5, yes, absolutely. But whenever you throw in a square root, it cannot be a Pythagorean triple, even if it is a 90-degree triangle, okay? Anyways, so yes, this is a right triangle, but these numbers are not a Pythagorean triple. That is your correct answer on this one. All right, if the sides are 15, 30, and 34, let's work that out. So how do I set it up? The Pythagorean theorem is a squared plus b squared equals c squared. Which one do I put for a? Which one do I put for b? Which one do I put for c? 15 squared plus 30 squared equals 34 squared. Thank you very much. 34 squared. Okay, so on a calculator, I am going to do 15 squared plus 30 squared, hit equal, it gives me 1,125. And we need to check if this 1,125 is equal to that 34 squared. As you could see, I typed in 34 squared, I got 1,156. So what does that tell you about this triangle? That what? It's not a right triangle. It's not a 90-degree triangle. So this is no, it's not a right, can't spell, triangle. Not a right triangle, which obviously, if it's not even a right triangle, then these are definitely not a Pythagorean triple. So which one are you going to pick? You're going to pick this one. No, this is not a right triangle, and the numbers are not a Pythagorean triple. So that's pretty much the whole lesson. I hope this helps, and this will be posted later on YouTube and on Google Classroom.